mean that this portion here, autoregressive portion, but in the breakdown is removed. Air portion is removed when constructing the standardized proxy. And now the proxy are transformed and retrained. Transform and retrain. So how they transform? They use they impose that this version inside here and retrain. So they retrain the series. So they retrain the series. So your parameter is still estimate from the pure proxy equation. So once you construct, then use this one as a dependent variables, and your series here become your independent variables. This one. So this is how they construct the test statistic. So now, in construct the LLC no kernel computation, then you will ask, right, actually which one is much more powerful, right? So can we compare with the years? Cannot, right? Because this one just like the complement each other. By the time series, right? You first start with the ADM, then complement with the what we say the PP, right? PP, and then with the KPSS, then also with the unparent. So we will compare. Actually, for example, how many test statistics suppose that the variable actually is I0 or I1? So like complement to each other. It's different with the cross dependency test, right? Depends on the size and also the power of the test. So how we can use this one to run EViews to run this breakdown? You can go to the unit root test against to test. When you scroll down, we can check for the common root breakdown. Then again, you can test for the levels. Then for this breakdown, right, is only allowed for the intersect and train. Right, intersect and train. This is for the retracted, right? So intersect and train only allowable under the breakdown. So it means that you do not have any choice to test with the breakdown to test for the series, because it's only you can include the intersect and train in the breakdown's test auxiliary regression. So again, you can check, okay. Then you found the entry, the option like here, right? Actually, there are which option you might confuse, right? Which option you should choose to select the right. So again, it's based on your something I cannot say very subjective. It's based on your argument why you want to use that modified AIC, for example. Because you found that the AIC actually is not that valid, right? So you want to use a modified version. Or why I want to use the modified SIC, right? So just I leave it to you to discover. So against SIC to use because of my short sample, I use a modified version to accommodate the limitation in the conventional SIC. So I say okay. So against the test statistic is insignificant. The test statistic is insignificant. Then the result here it gives me that the individual that the residual sum of square, right? Residual standard error of the regression. So 4.6 is significant. So again, not significant. So due to reject. So based on the breakdown, my investment or now it's VAL, right? My VAL series is non-stationary. So if you want to test for the first difference, then you go for the first difference, go to view, and then go for the first difference, right? So something like that. So now, so this one breakdown different from the LSD is the non-contained AR, and then the proxy are transformed and retrained. So these are the something like innovation in the breakdown as compared to the LLC. So how about the Hartree? Hartree come out a little different. Because of this Hartree, actually the idea is similar like KPSS. So because of the power to reject the uniroot now, right? So the Hartree come up with a test, no uniroot as a noun. No uniroot as a noun, right? So Hartree test is based on the residual from the individual OS, and either based on constant or constant or trainer. So again, there are two different things. One is the homoscedastic assumption. The other one is a test to allow for heteroscedasticity. So these are the two different test statistics, and to come up with the you take a look at the last, you have to bear in mind that, so some researchers, based on the simulations exercise, they found out that small t, for example, hardly has experienced a significant size distortion. Yeah, when there is a presence of this autocorrelation, when there is a non-uniroot. So you have to bear in mind that if you have a small t, for example, so if there is a non-uniroot, maybe if there is stationary, you might have the size distortion. So you have to make sure you have enough t apply for the big sample size, for example, big sample size. So this is just like so we have to make sure our sample size is good enough, or else to apply the Hartree test. So now, how are we going to use this test apply with the test statistic for our sample, for our analysis? So we go to the equation, again go to the view, uniroot test, cross-sectional independence. Then for the test type, you can choose the last option, the Hartree. Again, now we actually running the common root. What is common root? We assume that the rule is actually similar for all the cross section. So it's a common root. So now I'm testing with the individual intercept. So now that line is no longer there, right? It only has the band 1. It's similar like the KBSS, but it's only the band 1, no longer in the left line. So then you see a significant error, right? Are you happy? Because it's going to reject. So now you have to be careful that the Hirschsprung is stationary. Stationary as a Hirschsprung. So if you reject, means what? Reject means you reject the stationarity. So the result actually shows that the CAP now is non-stationary. Because you reject the non-stationary now. You reject the stationary now. You reject the stationary now. So your result shows that the CAP actually not stationary, or CAP actually uniroot. CAP uniroot. There are two tests here. So what is the difference? One is assumed HOMO, the other is hetero. So just now, the first one is associated homoscedastic assumption. Another one is allowed for the heteroscedasticity across the arm. So you see the difference on LM1 and LM2. So where is the difference with test statistic? One is I think here all same, right? Here all same, only the thing is the F. The F here, right? The F here is average of the residual spectrum at the frequency 0, but here is not the average. So it's allowed for the heteroscedasticity. So it's a different treatment for these two statistics. So that's why it's hetero, and even though HOMO or hetero, both also shows that the result actually not stationary. Okay. So how about another 3 more tests? IPS, Fisher, ADX, and Fisher PP. So now we're going to discuss that the non-common uniroot means that the PI actually freely across the cross-sectional. So the PI is non-common, not common. So actually what is called as a test with the individual uniroot process. So the IPS, Fisher, ADX, and the PP actually allow for the individual uniroot process. So that the PI different across the cross-sectional is a different. PI is not common. It's no longer common. It's different across the cross-section or across the fruit in our example. So what are the 3 tests that assume not common uniroot process, IPS, and also the Fisher ADX and Fisher PP? So first one is IPS 2003. So IPS actually refers to the unprecise machine, separate the ADF from each cross-section. So separate that run the ADF regression for each cross-section. So if I have 10, right, 10 terms, it means that the IPS suggests that to run that the ADF test for 10 terms. To run the ADF regression for 10 terms. ADF means refer to that changes in the Y on that lag for the Y, and also the AR, right? And also the lag dependence. This is a lag dependence, means the lag for the changes for the Y. It includes that the trend or the constant as an exogenous variables. So what is a H now? H now is alpha I equals to 0 for the all I, so it's a uniroot as a H now. Uniroot as a H now. So the alternative will be not equals to 0, right? It's not equals to 0 means stationary as a H now. So now, after we estimate, right, it means that the IPS say that after we estimate that the 10 regression, for example, for 10 terms, 10 ADF regression, that they only calculate that the average test statistic. Yeah, so this is the how they calculate the test statistic. After they estimate the 10th ADF regression, then get the average of the test statistic for the each firms. Yeah, for the each firm. For the each firm. Get the average. If I have 10, then divided by 10, then to get the MPS test statistic. That's why it's do not have a common uniroot, right? So that is the idea behind this IPS. So this is my result. Again, insignificant. So uniroot again for as a level. Then my null hypothesis is become individual uniroot process. Because the idea behind this IPS is estimate 10 times, 10 terms, they only get the average for the test statistic. So it's different compared to this Hartree, compared to the LLC and Brito. So how we can conduct? You can go to the view again, uniroot, cross-sectional independence, then check for the IPS. Then you okay, so this is how I can get my result. Then you want to check for the whether it's I1 or I0 or not, you go to the view, uniroot, and then cross-sectional independent, then go for the first difference. So then my p-value becomes significant. So you reject. So actually it's once your first difference the series, then the p-value is significant at 1%. So it's I1 at 5%, at 5%. Then how about Fisher ADF and Fisher PT? So this is a test proposed by Mandala and Wu in 1999 and Choi 2001. So what is the difference here? So this is an alternative approach to use the Fisher result to get the test statistic. Actually, it's combine the p-value from the individual uniroot test. Yeah, it's combine the p-value from the individual uniroot test. So we did not discuss the test in the previous class. We just understand that this one is allowed for the individual uniroot. Is combine the p-value from the individual uniroot test and proposed by Mandala and Wu and Choi. So now, so we're going to have the something like this review. So you can see after you run, you're going to have the Fisher, chi-square, and also the Choi Z statistic. So again, these two also shows that it's insignificant. So you for the details, right? For example, the Choi is when this item is inverse, it becomes the CDF function, CD function. So now we go to the view and then go to the uniroot test, check for independence. Then you click for this ADF, right? Then you click for the level and then check for it. So if you go for the ADF, then this is the Mandala and ADF and also the Choi ADF. We also got the Mandala and Wu and Choi for the PP. Actually, it's based on the ADF idea. Run the ADF and then compare the PDF, right? Compare the p-value and then calculate from there. So that's why it's called Mandala and Wu ADF test, ADF and Choi also. Then how about this another one is PP. So we click OK, so there is a test statistic. So how about the individual one? Actually also can get the individual PP test. So these are the individual PP tests, individual. Because it's a combined, right? It's a combined p-value from the twins and parents, right? So this Mandala and Wu and Choi PP test actually is based on like a p-value, individual p-values. So that's why it's extension because twins parents can come up with a test statistic, right? Based on the p-value and this Mandala, Wu and also Choi. Based on this p-value and then construct their own test statistic and then make a conclusion based on the test. So there is something like the extension for a time series because we understand that the twins parents and NDF actually is a time series. So this Mandala and Wu and Choi come up with a panel form of the twins parents test. So these are the test statistics. So this we can see a difference between the time series and panels. So how they make it is actually combine the p-values from the individual, either from the NDF or the PP, right? So how they make the conclusion is, this is also insignificant, right? They are not significant. So based on the first noun is unit. So what is the general idea here? For all my result based on that the panel unit root, either I assume the common unit root or the individual unit root also shows that all my three series actually is I1. Right? I1, right? Yeah, all I1. So all is I1 series integrated of order 1. I will need to first differentiate only stationary. So that's my conclusion. Then there is a way entry. If you observe that once we go to that unit test, there is a summary, right? Yeah, there is a summary. What's that? Summary means that summary for all your results. There's no need to run one by one, right? So once we click OK, there is a summary. Summary actually is just report the LLC, just report the IPS and the activity. Where is Breton? Breton is not for the only allowed for the concert and train, right? But now I'm running just individual intersect. If I run it, the intersect and train, so Breton is come up. Because the Breton test only test for the intersect and train in the test equation. So this is how we perform the summary. So again, this summary LLC and Breton is assumed common unit root, and these three other tests is for the individual unit root. So all the results shows here the p-value actually is insignificant even at 10%. So they are due to reject for the CAP, right? For the CAP. For a CAP series. And you say, where is Hadri, right? Hadri is different. Hadri is not appeared here because Hadri is a stationary as a noun. So if you want to run the Hadri test, you have to run independence. We have to run separately. We have to run it separately to complement my summary. So these are the tests because they share the different platform compared to the others tests where there's a unit as a first noun. Okay? So that's the things for me, right? For me to share with you today. Actually, if you want to test for the individual series cross dependency, right? Actually, I think that's here, cross section dependency test. So this is a test for the CAP. So the same idea, just like you apply for the CD test, the cross dependency test for the residual. So now it's a CD test for your series. So again, they are similar idea like the Bush-Buckley LM test, personalized QLM, bias corrected one, proposed by Buckley et al. 2012. Personalized CD is for the CAP series. So this is not for the residual, it is just for the individual series. So now you have two different types of CD tests. One is for a similar person to test for the cross dependency. One is for the residual. The other one is for the series itself. So based on this CD test, then you found that actually all the tests here shows that, for example, CAP is actually suffering from this CD, right? The cross-section actually dependence, right? The series here actually shows that there is a cross-sectional dependence. So that's why can we still rely on the first generation panel unit test to say that actually all my three series I1. Yeah. So this is the question for you to proceed to the next lecture. Maybe I can rephrase my question. Based on this CV test, it shows that there is a cross-sectional dependence. Is it my result just now which conclude that all my 3 series IME, CMP, and BAL actually is I1? Is it my result still valid or not? Based on this result. Yeah, because this shows that there is a cross-dependency, right? And now all my first generation unit tests actually assume cross-sectional independence. Is it my I1 conclusion still valid or not based on my CV test? Yeah. Okay, that's all of it for today. Let's go back home and enjoy your days. So let's meet online next week. Yeah, see you all next week, Wednesday, 6:15.